Okay, so today we're gonna be evaluating this limit. More specifically, we're gonna be showing that this is equal to 1 over e. I took this problem off Instagram Reels, by the way. So first thing we're gonna do is we're gonna set this limit equal to L. And since we're trying to show it's equal to 1 over e, let's just take the natural log and see what happens. So this is equal to ln L is equal to the natural log of the limit as n approaches infinity of, I'm gonna rewrite this a bit, n factorial over n to the 1 over n. Makes sense, right? Makes sense. Okay, now we're gonna bring this natural logarithm inside. So we get natural log of L is equal to the limit as n approaches infinity of the natural log. Actually, I'm gonna put the 1 over n in front. The 1 over n times the natural log of n factorial over n to the n. Now I'm gonna take the term inside the limit and rewrite it a bit. So let's just take n factorial over n, and we're gonna rewrite this as the product from k equals 1 to n of k, and we're gonna take the denominator and rewrite it as the product from k equals 1 to n of k. And this is just equal to the product from k equals 1 to n of k over n. So 1 over n times the natural log of n factorial over n to the n is actually equal to 1 over n times the natural log of this product sequence, k equals 1 to n of k over n. Now let's just try writing some of the terms in the sequence. So natural log of, I'll just put it as k over n times k1 over n. Actually, I should write it as k1, k2. Okay, k1, k2 times k3 over n, all the way to times n over n. So notice that it's all being multiplied. It's all multiplication, and there's actually a logarithm property for this that we can use, and this will make it equal to 1 over n times the natural log of k1 over n plus 1 over n times the natural log of k2 over n plus 1 over n times the natural log of k3 over n, and this goes on all the way till 1 over n times the natural log of 1. So what now? The question just looks more confusing than it was. But notice that this is a bunch of stuff being added up, and we can actually connect this to a summation. So first, what I want you to notice is that the integral, the definite integral from a to b of a certain function f of x is equal to its Riemann sum, which is just the limit, this limit as n approaches infinity, the sum from I equals 0 to n of some f of x times some change in x. And notice that this whole logarithm was originally inside a limit as n approaches infinity. So if we can rewrite this as a summation, we can rewrite the entire limit as a definite integral. So let's try to do that. And what we can actually do to rewrite it as a summation is take f of x, let's just take x to be equal to k over n, f of x to be equal to the natural log of x, And finally, the change in x to be equal to 1 over n. And for the definite integral, I'm just going to consider the interval 0 to 1. Because we can choose any bounds because it's an AB and it doesn't really matter here. So we're just going to pick something really simple, like 0 to 1. So we can just rewrite the natural log of L as the definite integral from 0 to 1 of natural log of x. And if you didn't know, this is just equal to x times natural log of x minus x, evaluated from 0 to 1. So this is equal to just natural log of 1 minus 0 times the natural log of 0 plus 0, which these terms don't really make a difference. This term also doesn't really make a difference because it's just 0. So it's equal to negative 1, sorry. And finally, we know that this is equal to the natural log of L. So L is equal to e to the negative 1 power, which is equal to 1 over e. And we are done.